Hello everyone and welcome back to my channel. Today we will discuss an interesting topic about brake energy and airplanes. I hope it will be interesting for you and you get the required knowledge out of it. What pilots need to do after landing is quite obvious. They need to decelerate and stop the aircraft safely on the runway. This looks simple by saying, but in practice, to decelerate an aircraft with tons of weight and high speed needs proper brake design and the pilot's attention. Understanding brake energy is key to enhancing safety and efficiency in our operations. So, what exactly is brake energy? Brake energy is the kinetic energy that our aircraft must dissipate during landing and taxiing. In other words, we should convert the kinetic energy into heat energy to stop the aircraft safely on the runway. This is the main job of the brakes. The main job of the brakes is to change the kinetic energy into heat energy. Brakes and brake systems are designed to be applied either manually or automatically. When we touch down after a flight, the aircraft comes in with a significant amount of momentum, and that energy needs to be transformed into heat through the brakes. It is a fascinating process that plays a vital role in ensuring we come to a safe stop. So colleagues, before we continue our discussion about brake energy, let's have a look at braking systems on modern commercial jets. On a modern airliner, stopping is just as important as flying, and there are multiple highly reliable systems to make sure it happens smoothly and safely every time. The main stopping power comes from carbon multi-disc wheel brakes. They are advanced brakes that are squeezed together by hydraulic pressure to create friction. Carbon brakes are lighter than traditional steel ones, absorb and dissipate heat better, and last longer, which means more landings before replacement. Working alongside the wheel brakes is the auto brake system, which automatically applies a pre-selected braking force during landing or rejected takeoff. This not only gives consistent deceleration, but also lets the pilot's attention and focus to be paid to monitoring the runway conditions and aircraft performance. For extra help, commercial aircraft use thrust reversers. Thrust reversers are devices in the engine nacelles that redirect engine thrust forward instead of the backward, and adding powerful deceleration. They are especially valuable when landing on wet or icy runways, and they reduce the wear on the wheel brakes. So up on the aircraft wings, we have the spoilers, also called speed brakes, deployed to kill the remaining lift that wings produce after touchdown. So this forces the aircraft's weight fully onto the wheels, letting the brakes grip harder while also adding aerodynamic drag. If the main hydraulic source fails, Pilots can turn the emergency brakes powered by alternate hydraulics or stored accumulator pressure, ensuring braking capability is always available. And on the ramp, parking brakes keep the aircraft firmly in place during boarding, unloading, or towing. Tying it all together is the anti-skid system, the aviation equivalent of a car's ABS. It prevents wheel lockup, maximizes braking efficiency, maintains steering control, and protects the tires from damage. All these systems work in harmony: carbon brakes, auto brakes, thrust reversers, spoilers, emergency backups, and anti-skids, turning the huge momentum of a commercial jet into a smooth, controlled stop. It's a perfect example of how modern aviation blends engineering, safety, and precision into every single landing. So, now let's explore why managing brake energy is so important. First and foremost, there is safety. Overheated brakes can lead to failures, which is a serious concern during landing. If brakes get overheated, their efficiency will significantly reduce. In such a condition, fully applied brakes will not help to decelerate the aircraft. The chance of runway incursion increases and, in some instances, catch fire. We must ensure our braking systems are reliable because the safety of our crew and passengers depends on it. Next is the maintenance. Excessive brake energy can lead to significant wear and tear on the brake components, resulting in higher maintenance costs and potential downtime for the aircraft. Finally, we have the performance. By effectively managing brake energy, we can enhance the aircraft's overall performance, resulting in smoother landings and a more comfortable experience for everyone on board. Colleagues, some factors influence brake energy during landing. One of the most significant factors is the aircraft weight. A fully loaded aircraft generates more kinetic energy, which means that more energy needs to be dissipated during braking. Similarly, landing speed is crucial. The faster we land, the more braking energy we need. And we also have the runway conditions to consider. Wet or icy runways can affect braking efficiency, leading to longer stopping distances and increased brake energy. And lastly, the design of the brake systems matter. Modern aircraft come equipped with advanced braking technologies that enhance energy dissipation, improving overall braking performance and safety. So, how to effectively manage braking energy? There are some best practices to follow. First, focus on proper landing technique. Aim for a stable approach speed and a precise touchdown point to minimize the amount of brake energy required, in fact, of the landing. Using reverse thrust is another effective strategy. It can substantially assist in slowing down the aircraft, reducing the burden on our brakes, and regular maintenance is essential as well. Routine checks and timely replacement of the worn components keep our braking systems in peak conditions. Additionally, make use of braking management systems available in modern aircraft. These systems provide valuable insights into brake performance, allowing for informed decision making during landings. And lastly, ongoing training and simulation exercises focused on braking techniques can help us hone our skills, fostering a culture of safety and operational excellence. Okay, colleagues, as we are at the end of our discussion on brake energy, understanding and managing brake energy effectively is not just about numbers. It is about ensuring the safety and comfort of everyone on board. So, thank you for joining me today. If you found this presentation helpful, please like and subscribe to our channel for more engaging aviation content. Wishing you all safe flying and clear skies ahead. Thank you very much.